Finally, our review of Intel's new consumer-grade flagship Skylake CPU and Z170 chipset is here. That's right, I said flagship, which probably seems a little strange considering Intel's previous top-end quad-core, codenamed Broadwell, haven't even been on the market for 3 months on the desktop side. And although Intel has gained a pretty big market advantage over AMD, partially due to how regularly they release CPUs and chipsets, the past few processor architectures have merely felt like incremental upgrades to a lot of people, with many gamers and enthusiasts like me still happily rocking their Sandy Bridge chips from 2011. 2600K for the freaking win. So, what does Skylake bring to the table, and is it the next big thing? Like the video if you want to see us check out a 3D printer called the Ultramaker 2 Extended. The Logitech G303 features lightweight design and advanced optical sensor with Delta Zero technology for precise tracking and RGB lighting to match your setup. Click now to learn more. Let's start out with a look at the CPU itself. This is a Core i7 6700K, and just like all of its other K-series i7s, it features 4 cores, 4 hyper-threads for a total of 8 threads, and an unlocked multiplier for overclocking out of the box. You'll get a 4.0 GHz clock with the turbo boost frequency of 4.2 GHz. Now, if this doesn't sound like a big improvement right away, that's because Intel's last-gen 4790K ran at the same base clock speed, but while the CPU may not have incredibly eye-popping specs at first glance, the Skylake platform does come with quite a few improvements we haven't yet seen on mainstream chipsets. For starters, DDR4 support is finally available for cheaper motherboards, with Skylake supporting up to 2133 MHz DDR4 RAM. Gone are the days where you had to pay $1,000 for a 6-core CPU and straight baller board just to try out some memory. It really doesn't make much of a difference. Anyways, check this video out for more on the differences of DDR4 and DDR3. Skylake also comes with revision 3.0 of Intel's Direct Media Interface, or DMI, which is basically the thing that connects your CPU to the chipset and many of your computer's other components and peripherals. It's twice as fast as DMI 2.0 on Haswell and other earlier processors, and given how DMI's 4 lanes carry 20 lanes of PCI Express bandwidth to and from the CPU, the extra speed should help if you happen to be running a whole bunch of high-end stuff like big external storage, high-speed PCIe SSDs, or just downloading and streaming tons of stuff through a big internet pipe. Skylake also includes some serious improvements on the graphics side as well. Now I know that many of you, like me, are going to be running Skylake with a discrete graphics card, but remember, Skylake series is going to include lower-end chips like Core i3s and Pentium, so if you are using the integrated GPU, maybe inside an HTPC or something, you'll be able to enjoy the full support of HEVC codec, the successor to H.264, which is newly supported in Windows 10. Skylake also includes native support for Thunderbolt 3.0, which has 5 GB per second transfer speed, which means it is also fast enough to output 4K 60Hz video over HDMI or 5K 60Hz video over DisplayPort. Very cool. So, how well does this thing overclock? Well, first, Intel's had a few issues with several overclocked CPUs. Both Ivy Bridge and Haswell had some well-publicized issues with excessive heat, so much so in the case of Haswell that Intel's refresh of Haswell, Devil's Canyon, had improved thermal interface material as a major selling point. So Intel's tried to reduce heat output on Skylake by doing 2 different things. One was improve power efficiency, and 2 was move the voltage regulator off the CPU and back onto the motherboard to reduce the amount of crap that's actually heating up the CPU package. So even though the smaller 14 nanometer process could otherwise result in higher overall temperatures, these changes should result in a relatively easy overclock on a wider range of motherboards, including cheaper ones that don't have the fancy 8 or 12 phase power VRMs. And early tests show that it actually won't be nearly as much of a variance between individual chips as well, which is nice. You won't have to hunt for certain bins anymore. Hopefully. It's benchmarking time! For our test bench, we used the new ASUS Z170 Deluxe motherboard with our Core i7-6700K, along with 16GB of DDR4 2400 MHz RAM, a Samsung 850 Pro 1TB SSD, a reference GTX 980 Ti, and a Corsair 100i GTX liquid cooling cooler. We took this setup and put it up against a Devil's Canyon Core i7-4790K running on an ASUS Sabertooth Z97 Mark I, also with 16GB of 2400 MHz RAM, albeit DDR3 instead of DDR4, and kept the rest of the components the same. To get an apples-to-apples comparison, or as close as we could, given that the two CPUs are different and use different types of memory, we overclocked both chips to a stable 4.7 GHz on 1.4 volts. We used PCMark 8 to test general performance and Cinebench along with 7-zip to give our test bench a CPU-bound workload. Our overclocked Skylake chip showed slight improvements over Devil's Canyon, perhaps not enough to notice in everyday situations. Our gaming benchmarks told somewhat of a similar story with virtually no difference in Far Cry 4 and City Skylines, but we did see about a 7 FPS improvement in Total War Attila, which is pretty CPU-sensitive title that also really pushed our GTX 980 Ti at max settings. So although Skylake isn't a massive improvement clock for clock over the previous generation, only about 4% in PCMark 8, is it still a compelling upgrade? Well, if you're running an older chipset, looking for a more consistently solid overclocking experience on mainstream motherboards, or want a specific feature set like Thunderbolt 3.0 support or massive bandwidth for things like your expensive NVMe drives, or Skylake is going to be certainly worth a look. But if you're not a super serial overclocker or you're a gamer with a newer platform like Sandy or Ivory Bridge, it might make more sense to spend your hard-earned cash elsewhere. If you're building a mobile app and are searching for a simple payment solution, you should definitely check out Braintree. They offer code for easy online payments through their Braintree V.0 SDK. You can get set up in less than 10 minutes, and if you have any issues during setup, you can contact their support staff who are ready to walk you through the entire process over the phone if need be. Their code supports Android, iOS, and JavaScript clients, and they have SDKs in 7 programming languages. With Braintree, you can accept PayPal, Apple Pay, Bitcoin, Venmo cards, and more, all with one simple integration. And as I said before, they have support staff at the ready. So if you have any issue at any point while setting up Braintree, they're there to help. So to learn more about Braintree and to claim your first $50,000 in transactions fee-free, head to braintreepayments.com/Linus. Thanks for watching, guys. If this video sucked, you know what to do, but if it was awesome, get subscribed, hit that like button, or even consider supporting us directly by using our affiliate code to shop on Amazon, buying a cool t-shirt that isn't necessarily from Twitch, or with a directly monthly contribution, and on the forum. And now that you're done doing all that stuff, you're probably wondering what to watch next. So click this little button in the top right-hand corner to watch a video that is the start of our moving forward.